Welcome to this video about the template pattern or template method design pattern. So I'm going to show in this video an example of the template method design pattern. I try to come up with something like a coffee machine, something like a controller for a coffee machine, because I think could have its uses there, but it's still like textbook, school book kind of example, but not too crazy like some of the other examples that I've seen out there. So basically the template method design pattern is, the idea is that we define the skeleton of an algorithm in an operation. So kind of if you have something that always needs to be done, you have a superclass that always does some steps, and then some of the steps are different for the subclasses. So it's kind of like you have the template, which you always do, and then you have some things that you're going to do differently. So in this example here, there's like a framework class where you have a template method. And in this case, for example, the template method is what's going to be done here. And then application class 1 does step 2. And then application class 2, it also does step 2. So it says here, implementation of template method is call step 1, call step 2, call step 3, and then step 2 is the hook method. It's a placeholder method, so it's kind of declared in the base class. So here's an example from a sorting algorithm. So we have sort, compare, return array, process array. So the difference is put out into these two. So when we sort the algorithm, the comparing of the two is different. So the sorting algorithm will say process the array, compare, and then return it. So here's an example. So there's the daily routine, then we get up, then we eat breakfast and go to work, and the work is then different for each one of them. And then this manager also gets to relax, which is pretty nice. But yeah. So the subclass is then, for this, it overrides the work and relax method from here. So relax and work is in here, but they are overwritten here by these because they will do them differently. So basically everyone does the same thing, but the work they do is different, and the manager also does some relaxation where the others, maybe he does more relaxing. I'm not sure about that. So let's try to take this into something. I want to try to program it. So I'm going to create something like a controller for a coffee machine, because I think in a coffee machine that will be able to, for example, make a cappuccino, it will be make espresso. There are still a lot of things that needs to be done, like heating up the water and stuff like that, but it will be different what it does based on the ingredients that it put in. So let's try to use that as an example. I started out with like a totally nothing here. I have only a main class. All the other stuff is from my main repository on GitHub, design patterns example. So I'm going to upload it there. But let's start out with something like a coffee machine. So first off, I'm going to make the coffee machine. So the coffee machine is like the worker here. This is kind of like the template class. So let's start by creating that. So I'll create a new Java class, and I'll call this one coffee machine. So now I have a coffee machine. And the next thing for the coffee machine is that I'm going to make a template method. So I'm going to say public void make coffee. And whenever we make coffee, we need to say something like heat, water. We need to do something like brew, coffee, because we do this for all coffee. And then we have something like pour. Oh, sorry about that. Pour in cup. And maybe also something like add ingredients. Hard one to spell. Something like this. So I have these methods. So what I'm thinking is that maybe we should, before it brews the coffee and then it pours it in the cup. So this one heats up the water, self-explanatory. Then it brews the coffee, like mixes the water with the coffee, and then it pours the coffee in the cup. And then sometimes if we want to do something like a different kind of coffee, we put in more stuff, like we put in for cappuccino, we add some extra ingredients, and that we cannot define in here because that is what is different. So this is kind of like these are like our template methods. And this is kind of like our more like special methods. So of course, any one of the sub classes could, override these. We haven't made them final or anything, so they can override them. But this one, I think we want to make special so that every class, these subclasses that uses that, we wanted to always implement the add ingredients. So it's like the work here, like everyone needs to work differently. So I don't want to define what work is in the worker class. I want to define it in the subclass. So let's try to do that. So make coffee, then we need to make all of these methods, of course. So let's try to do the heat water first. And let's just print out heating water. Put some dots here like we're waiting or something. And the next one we want to brew the coffee. We'll wait. Brewing coffee. Oh, it's so nice. And the last one, pouring cup and pouring cup. Yeah. So now we have those. And the last one, add ingredients. I could define it with the default behavior in here like this, like adding, we could say something like no ingredients to add, something like that. But I don't want to do that. I want each and every subclass to add the ingredients. So instead of that, what I will do is I want to make this one abstract. So now this method is abstract, but the class is not. So I need to make the class abstract as well. Otherwise, I cannot have abstract methods. So that's it. So now I have a coffee machine that will make coffee by heating water, brewing coffee, pouring it in cup, and then adding the ingredients. And I have the abstract one here. And one other reason for making the coffee machine abstract is I don't want the coffee machine in itself to be able to make coffee. I want to specify which type of coffee I want first. So let's try to make one of the simplest ones. So espresso, for example, we heat water, brew coffee, and pour it in the cup. That's actually espresso. No ingredients needed. I don't know how much you know about coffee, but that's how it is. So espresso, we do like this. And, oh, sorry about that. And then we, of course, we want to extend coffee machine. So why do we want to extend coffee machine? Because if we look at in here, this is extends, this is inheritance. So now espresso extends the coffee machine. So now we have an error because, we need to define the abstract method, and that's the add ingredients. And for this one, actually we have to do it, but there's actually nothing to add. So maybe I should just print something like not adding anything. This is espresso. So that's it. So before I do anything more, let me show you how this works. So if I go in here now and I'm going to say espresso E equals new espresso, and then I can say E dot brew coffee, right? Let's see what that does. We'll take a couple of seconds, and it says brewing coffee. Okay, so let's go look at the brew coffee method on the coffee machine. So it says brewing coffee, so it only does this one for some reason. Let's go back to the espresso. Let's see what's going on here. Make coffee. Let me just 2 seconds. Oh yeah, now I know. So I accidentally put the names a bit too close, you know, brew coffee, like make coffee. Oh, that's a bad naming. I'm not sure I like that. So make coffee. I think I want to rename that, you know, if I let me run this just so you can see it works out now. So what we can see is that it heats the water from the template, it brews the coffee from the template, it pours it in the cup from the template, and then it doesn't add anything because this is an espresso. So it kind of works like that. Let's change the name. I really don't like that. So the make coffee, like make drink, I'll call it that. And then we'll just change that in here to make drink so that we are not confusing those two. That was like an annoying mistake that I made. Okay, so you can imagine, so this is espresso, for example. What if we want to make a cappuccino, for example, right? So then I would go create a new Java class, cappuccino. I can spell that. And the cool thing is, now that I have my cappuccino, only thing I need to, not a main, I need to extend the coffee machine like that. And now that I'm extending coffee machine, it says I need to add the ingredients. So I remember that. Okay. So then the cappuccino can have its own methods like private, like void, like add frothed. I'm not sure how to do that. Milk or something like that. Yeah. And then simply just printing something like adding maybe frothing. Maybe something like make frothed milk and then like frothing. Something like this. And then we can do make frothed milk, like, and then something like pouring milk into drink. Something like that. So I save that. And the cool thing, if I go back to my main now, oh, sorry, wrong main. I have so many classes open here. And then I create a cappuccino. I can then say cappuccino, C equals new cappuccino, and I can say C dot make drink. And if we run that, we'll see the difference between the two. So we can see that the espresso is heating the water, brewing the coffee, pouring the cup. The same thing heating water, brewing coffee, pouring cup, same thing for both of these. And then the espresso is not doing anything because it's just espresso. And then the cappuccino is frothing inside of itself and then kind of like pouring milk into the drink or something like that. So now we have a cappuccino drink. And it seems like a stupid example because I'm just printing out here, but you could imagine it's not this stupid, because instead of printing out pouring milk into the drink, we could contact, you know, some hardware that would actually pour the milk into the system. So we could actually have this use, but of course I'm not going to do that, you know, doing hardware integration to show you this small example here. I'm just saying it's not as stupid as it might seem out of the box. So yeah, so that's kind of the idea of everything. I only have one more thing that I would like to show, and that is that one thing that we might want to do is, we don't want, if we go into our coffee machine, this method is kind of special, like the make drink method. So as it is right now, we can override the make drink method. So it kind of defeats the purpose of the template, because in the template we want to run the template methods always, right? So it doesn't really make sense. If we override the make drink, we break everything. So what I would do here is I would make it final. So that means that we cannot override it from the other classes. So if I make like a make drink method in here, like public void make drink, then then we'll get an error, right? Saying, oh, you cannot make a drink because it's final, so you can't do this, right? We don't want to override the make drink by mistake. This override notation is actually optional. We can remove that, so we wouldn't even notice if I remove the final from coffee machine here. There would be no problem in this. We wouldn't even notice. So maybe I just wanted to make a method called make drink, and I wasn't even realizing I was overriding the one from the coffee machine and breaking everything. So it would be like nice to make this one final, just to make sure that, you know, we're not creating any problems like that. Yeah, I think that's it for the for this template pattern example. I'll upload it to my GitHub page, which is here, design patterns examples in YepML, and you can find it there. Thank you for watching.